Let's look at our word problem finally. So the height h in feet of water spraying from a fire hose can be modeled by this function. H of x is equal to negative 0.03 x squared plus x plus 25, where x is the horizontal distance in feet from the fire truck. The crew raises the ladder so that the water hits the ground 10 feet farther from the fire truck than this equation, and we want to write a function that models the new path of the water. All right, so we want our ground level or our distance along the ground level to be 10 feet further. So we want our horizontal distance to go further. Let's take a look at this equation in Desmos to help us out with modeling this. All right, so here I am in Desmos and I have put in my function. The first thing that I notice is that my y-intercept, which I actually could have picked out of the equation because it's always the constant at the end, my y-intercept is at 25. So that means that the fire truck ladder starts at 25 feet, and that's how it's spraying the hose. And as that hose comes across, it hits the ground being where y is equal to 0. It hits it at 50. So 50 feet away is where it lands on the ground. We are told that we want it to go another 10 feet. So we need it to reach another 10 feet in the x direction. So that would put us at 60. And at 60, I can see that the value of my y right now is negative 23. Well, I want negative 23 to magically become 0. So that means I need to add 23 feet to the height of the ladder so that I can go another 10 feet. Let's take a look back over at our notes where I'm going to mark up this Desmos drawing. Let's quickly summarize what we saw in Desmos. So from Desmos, I saw that in order to get a height of 0, in other words, hitting the ground, I was going a horizontal distance of 50. So my h, my height, when I was 50 feet out in the x direction was 0. However, we now want to be 10 feet further out. So we want h of 60, all right? And right now, h of 60 was equal to negative 23. So let's take a look at that on a markup of the Desmos graph so we can see exactly what's going on here. All right, so taking a look at our graph, and I can mark up on this one because I brought it into the notes. Remember that we started at 25 feet, so our ladder is here at 25 feet. In other words, we've got a fire truck over here somewhere. Please don't make fun of my drawing. This is just kind of a rough sketch here. And our ladder has extended up to 25 feet, and that's where our hose is coming across. And it hits the ground here at 50. We want it to instead hit the ground at 60. So what we need to do is make this point, which is now right now at negative 23, move up to where it's at 0 instead. And so in order to do that, every single point has to move up by 23. So that 50, 0 is now at 50, negative or positive 23. This point that was at the vertex is going to be way up here now. And what used to be at 25 is now going to be at 48. So somewhere about there. So our graph is translating up by 23 in order to make this happen. Something like that. All right, so we know that we need to raise our ladder by 23 feet in order to raise our point where it hits the ground by 23 feet. So let's say that up here. So we want to raise the ladder 23 feet. How do we do that? We tack a 23 on the end of the equation. So we can say that g of x is equal to our original equation, 0.03 or negative 0.03 x squared plus x plus 25 but then add another 23 to it. We can combine these two like terms and get a final answer that the first two terms are going to be the same, but combining the last two terms we get 48, and that is our final answer.